All right, welcome back, everyone. Um, I'm Jacob Gao, and I manage the As a Performer team at Pinterest. It is my absolute honor to introduce you to our next session, Lightning Talks. We have five really exciting talks lined up for this session. Each presenter will present for 15 minutes, followed by a 5-minute Q&A. So if you have any questions, please be sure to add them to public chat during our talks. Without further ado, we have our first presenter, Eric Sung, to present Pinterest Canvas.
Hi, everyone. Welcome. I'm excited to talk to you today about Pinterest Canvas. I think some of the previous speakers have alluded to this a little bit, but I'm here to provide a bit more detail about what's going on. Yeah, so without further ado, let's just get into it. So what is Pinterest Canvas? Pinterest Canvas is our own in-house text-to-image generative model. And so we've actually trained our own version of this in-house using our own data. We're hoping that this model, Pinterest Canvas, can sort of be a foundational model that powers a lot of different image generation experiences at Pinterest. And so we're not really that interested in like generating arbitrary content. I think we have a really focused, people go to Pinterest for inspiring ideas, and we don't want to change that. And so I think what we're really interested in is trying to take real ideas or real products that are currently on Pinterest and help users reimagine them in different contexts, maybe contexts that are more relevant to them, or maybe contexts that sort of present the product in a specific light and things like that. And so we've trained our own foundational image generation model, and we're using it to sort of try and revisualize or enhance existing products at Pinterest. So, diving into the technical details a little bit, Pinterest Canvas is a diffusion model. And so what is a diffusion model? It's different than sort of previous image generation models that have worked well in the past, like GANs. Diffusion models actually work over a series of time steps. We refer to this sort of diffusion schedule. And so the diffusion schedule just describes a sequence of images starting from pure noise and going to some real image in the training data set. Each time you run the model, it sort of iteratively removes a little bit of noise. And if you do this over and over again, what you actually end up with is some model that once it's trained, you can start from pure noise, remove a little bit of noise. And what the model is doing is injecting a little bit of an image into it, but the image is still very noisy. If you repeat this process over and over again, the model gets multiple chances to sort of slowly add image content into the image. And so you run this over and over again because it's seen your training data set over time. It learns to denoise from pure noise. It learns to generate something that plausibly resembles a real image. And so in more detail, kind of how this is trained is actually, we take that diffusion schedule, which is just varying levels of noise. We take our training set and we corrupt the images with noise. And so depending on the sort of time step that you sample along that schedule, there will be varying degrees of noise, which makes some of these images harder or easier than others. This diffusion model is trained to try and predict what the original non-noisy input should be. And then that's compared to the real original ground truth image in order to train the model. And so the difference between the model's output and the ground truth original non-noisy image ends up forming the training loss that we use for our models. And so after this whole training process, you end up with a model as described that sort of understands all steps along this diffusion schedule, and so can take it from pure noise, denoise it a little bit iteratively over and over again until you're starting to generate real images without any noise left. Additionally, kind of an implementation detail, but something that has become very popular with these sorts of diffusion models is to additionally use an autoencoder to compress the latent space. Images are very large, they're pixels, they're a representation that is intended for us to look at, but they're not very informationally dense, which makes it hard for diffusion models to generate them from scratch. And so we actually use a separate auxiliary model called a variational autoencoder. This compresses the image data into some smaller latent representation with the constraint that some decoder is able to then regenerate the original image. And the diffusion model then operates in this compressed latent space instead. That makes it a little easier to learn, makes these models more efficient, so on and so on. Then finally, what I've been describing is a diffusion model that just generates images, but in practice, it's a lot more useful if you can direct these models to generate a particular type of image. And so we tend to add additional inputs for conditioning. The most common or the most popular form of conditioning is to add some sort of text caption that indicates what the model should be trying to generate. And so here, if you have some caption like colorful shells with a potted plant, we can take some other text encoder encode that into some embedding, and then additionally provide this embedding as input to the model. And so the model is now not only getting some partially noisy image that it needs to denoise, but it's also getting now some textual input to tell it what the final image should look like. And there are many different forms that this conditioning input can take, not just text, but this is kind of the most common example. We'll end up discussing some more examples of conditioning inputs as we go. So these are all the various parts of how you might fit a diffusion model together. But putting it all together, you sort of end up with the sort of most standard form of a diffusion model, some image generation model. You start with an image on the left here. You encode it into your latent space using the autoencoder. That gives you some image latent. Then you noise the image latent some amount. So you add noise to corrupt it, and then you ask the model to try and repredict what the original image was, the uncorrupted version, given a text caption as input as well. And by decoding that that predicted latent, what you get is hopefully something that resembles the true original ground truth image before we added any noise to it. And so we take this basic training loop, we take a large data set, 200 million images, along with accompanying text data, and we show it over and over again, all of these different images with different text captions and different amounts of noise. And we train the model to be able to produce the sort of real looking images, regardless of how much noise or what caption we provide. And if we do this, we train it for a while, quite a long time actually, starting from low resolutions and then gradually working up to higher resolutions. We eventually end up with a model that is able to generate pretty good looking images, but kind of crucially for our use case, sort of understands the Pinterest aesthetic or Pinterest look better than other models would. And this is because we trained this model entirely ourselves in-house using our own data. And so we sort of know what's going into the model, and we are able to sort of vet the quality of it and make sure that it's representative of the types of images that we want to generate. And so we're able to generate at pretty high resolution, pretty good looking images. But as I kind of alluded to before, we're not just interested in generating images from scratch. That's not really useful to users. What we want to be able to do is use this as like a base model for empowering a bunch of different use cases. And so kind of a diagram of what this might look like is using Pinterest Canvas as this base foundational model, we might try to extend to something like virtual try-on, where a user might upload a picture of themselves. And then while browsing Pinterest, looking at different clothing items, they can sort of visualize what they might look like wearing that item. Or maybe some kind of home designer experience where we're allowing users to sort of take products that they see on Pinterest and then style a room, maybe their own room or maybe some studio room with these ideas to try and imagine what these items would look like together. Or even something simpler like just image enhancement, right? If users are uploading images that aren't that high quality, maybe we can do a little bit of super resolution or other types of enhancement in order to improve them. But the one I want to talk to today, and something that we've actually implemented and are using already, is outpainting, or specifically product backdrop outpainting. And so what is product backdrop outpainting? The idea is to take real products on Pinterest, like I've talked about before, but a lot of times these products are shot in a studio setting with white background, which is very nice and makes the product very presentable, but is a little plain sometimes. And so what we're interested in doing here is being able to take that product, and while preserving the product identity, we don't want to change it at all. Let's see if we can sort of present these products in a more interesting light by sort of painting the background around it. So these are real products, but reimagined in different contexts where the background is generated by our model instead. And so we're going to start with Pinterest Canvas as the base model, but we're going to extend it a little bit. If you look on the left here now, the model isn't just getting some original image as input. We're actually supplementing it with additional input. And this is what I was alluding to earlier when I was talking about there's a lot of different ways you can condition this model. We're actually going to provide the model 2 additional image inputs. One of them is a segmentation mask. And this mask is telling the model, these parts of the image are the product, don't touch these pixels, but do change these parts, the background. We're also going to show it what the product looks like without a background. And then finally, as usual, there's still the original image from our training set that we're trying to reconstruct. And so now the VAE is encoding not just the original image, but also the product image, as well as the segmentation mask. Again, we'll noise the original training image, but we'll also provide the mask as well as the product image along with the text caption. And now the model gets to look at all of this information when it's generating the final output. But the final loss is still the same as before. It's tried to reproduce the original image. We're just providing it a lot more conditioning input now. in the form of this product image and segmentation mask. This extra training step ends up being important because we do want the model to respect the original product, right? We're not allowed to change the product at all. It would be kind of a mess if advertisers were using this to generate additional backgrounds for their products, but their product was also changing as a result of this process. And so we enforce a lot of constraints to make sure that the product identity is preserved. Doing this, though, we end up with a model that is able to do exactly what it says on the tin. We're able to take a product and present it in a bunch of different contexts. And we can write a bunch of different descriptive captions to sort of present context. Maybe we want to show it this particular burner, we want to show it in a kitchen. And so we'll provide other things. Maybe we want to be a little more abstract in this case, so we'll use a planar background, etc. There's a lot of control that you have over exactly how your product ends up being presented, depending on the sorts of captions that you present. But these are real results generated by one of our models. And this was actually launched as part of some Performance Plus initiative at the beginning of October. And so we're really excited about where we've come with this technology. Of course, thus the model itself, there's still more work we can do to improve the quality of the results. And so we have a lot of extra rigging around the model to support it. In particular, we're not guaranteed that the model always generates perfect outputs on the first try. And so we have this whole pipeline where we actually try different prompts, varying levels of complexity, as well as multiple attempts at generating for that prompt. And so some of our prompts are saying this product presented in a simple context, whereas some of the prompts are a lot more ambitious. This product in some very exciting background, like maybe insight in the kitchen or something like that. And we take all of those different generations, and then we use some other model here, some ranking model, to select the best one out of those results. And that's ensuring that we're striking this balance between making backgrounds that are really inspiring and exciting, while also making sure that we're able to find one that meets our pretty strict quality bar. And so, of course, in order to do this, we use previous ratings that we've collected from real human raters, and we use this to train some in-house ranking model. And so this model is trained to look at generated images from Canvas and rate them from best to worst. So here's an example. For these glasses, we're able to paint a bunch of different backgrounds, but some of them are better than others. And our in-house model is able to sort of provide a guess as to, okay, these ones are probably more presentable to users. These ones have some weird artifacts, so let's not show these. And that ends up being an important part of sort of making sure that for any product, we can always find some useful generation to present to users. And so, as I alluded to before, we actually launched this as part of the Performance Plus suite at the beginning of October. We saw some pretty impressive results from initial trial runs. And so we're hoping that this sort of works well for all of our partners, but even just in the case of this one case study with Walgreens, where we saw a 55% higher click-through rate and 30% lower cost per click. And so we think that there's a lot of potential for this. We're going to keep iterating and improving in order to make this better and better. But this also isn't like the only thing we can do with this sort of technology. Backdrop outpainting is one of them, but we're also experimenting with things like Canvas aspect ratio extension. Pinterest has this unique quality. The grid layout of Pinterest sort of encourages you to prefer these vertical aspect ratio images, but people don't always take those. A lot of times, landscape images are more common. So we have some model that can sort of just invisibly extend the borders of the image by sort of generating what is outside of the extent of the original image. And so this can also help users create images that are more suited for the layout or format of Pinterest. We're also playing around with the idea of super resolution, as I alluded to before. And so if images are too low resolution, but users really want to zoom in and inspect the details, we can help sort of sharpen up some of those details and make it look presentable rather than blurry when looking at those sort of fine details present in the image. And finally, as a little teaser, one of the ideas we're also playing around with is this idea of being able to personalize what backdrops we generate based on users' interests. And so maybe we have different users that have different boards. One user is sort of into this Japandi home decor style, while another prefers this maximalist style. And so we're trying to see if we can, based on what other boards or pins users have interacted with, or perhaps even like a merchant's catalog, can we use that extra information to sort of guide how we generate backgrounds for these products as well? And so this ends up being more complicated, but the idea is still kind of the same, right? We just have this extra branch at the bottom where we're now taking additional conditioning images as well. And those conditioning images are then used as additional input to Canvas as well. And so it's this powerful basic idea of let's take some diffusion model and provide it all of the conditioning inputs it needs to be able to perform a wide variety of these image generation tasks. This is something that we're pretty excited about too. So look forward to it maybe in 2025. But this is a lightning talk, and so we have to keep the pace moving. And so I'll stop it here. But yeah, we're really excited about kind of Pinterest Canvas as a base foundational model for all of our image generation works. I'm pretty pleased to show off some of the stuff that we've been working on, and I hope next year maybe we'll have even more to talk about. So thanks. Happy to answer any questions from the audience.
All right, thanks, Eric. It's very exciting to see how a text-to-image generative model can bring so much value to our pinners and our advertisers. We now have Eric with us for a 5-minute Q&A, so keep the questions coming. All right, Arpita had this question for Eric. Are all the processing happening in the Canvas offline or online? Do you change the background, etc., real time for a user?
So one of the things that we're really concerned about anytime we're generating content is making sure that all of the content sort of is high quality and meets all of our safety and empathetic AI standards and things like that. So currently all of our processing is happening offline. And then we have a round of checks before we ever present those to users to make sure that everything is sort of meets all of our standards. And so right now the processing is happening offline. This also makes it difficult at the moment for this sort of real-time processing per user, but that is something we'd like to work towards. And so that will involve a lot of work in making sure that our safety checks can run in real time rather than necessarily having a high latency. And then sort of a lot of recent diffusion models have been showing really improved latency. And so I think this is potentially in our future, some sort of experience where we can sort of personalize to the specific context, like maybe users performing a specific search or a user has some specific board that they want to sort of visualize products in that context. That is something we'd like to work towards. But right now it's all happening offline so that we can perform all of the sort of rigorous checks that we want to.
Oh, thanks, Eric. That makes a lot of sense. All right, let's see. Andrew had this question. The ranking model, how do you make sure the artifact in the image generated for the Canvas model aren't abused to increase the score, like a pathological image that caters to the ranking model's flaws, feedback to a Canvas model so it learns to exploit the flaws of the other model?
So there's kind of two aspects to this question, though it is kind of getting at something that I didn't have time to talk in more detail about. So as described in the talk, the ranking model is only used as a post-processing step. So it's not feedback into the model itself, which means that the model doesn't really get the opportunity to learn these sorts of pathological edge cases to exploit the ranking system. But what I think Andrew is getting at here is the potential for doing some sort of reinforcement learning with that reward model to try and improve the quality of the outputs. And now once you have established that feedback loop between the reward model and the diffusion model itself, now you do have to worry about these sorts of issues. And I think this is not a unique to diffusion models problem. This is sort of a perennial reinforcement learning problem. There's a lot of techniques that people do in order to try these things, including, like, for example, trust regions, which are trying to make sure that you don't update the model too suddenly based on these sorts of things that can sort of keep you in some well-understood region. But ultimately, I think, at least in my opinion, the most important thing it boils down to is making your reward model as robust as possible, trying to eliminate these sorts of pathological edge cases as much as possible. And so a lot of what we're doing is just in the initial stages of this sort of Canvas product outpainting deployment, while we're still vetting the results much more carefully, we're using all of that data then to feed back into the reward model, and we're trying to generate across a wide variety of settings so that that reward model is as robust as possible. And that helps a lot also in making sure that the model can't sort of exploit weaknesses in the reward model. It's just having a really strong reward model. But I think, like, the answer to this question is hard to summarize in very short amounts of time and could end up being, you know, a whole hour lecture by itself. So that's the sort of short version of what we're trying to do. I think it's a really good question.
All right. Well, that concludes the Q&A with Eric. So thank you very much again. Next up, we have Jinjie Zhang, Sainan Chen, Aaron Lee, and this group will be presenting multimodal visual search at Pinterest.
Are we sharing screen? Yes. Hello, everyone. It's very exciting to share the latest. Yeah, cool. I'm very happy to present to you the latest innovation from Pinterest Visual Search. Irene Sainan and I are going to explain to you how multimodal visual search work at Pinterest. there are hundreds of users using Pinterest every day for inspiration and for exploring new ideas. And one of our advantage is the huge amount of information that's encoded in images, right? With like all sorts of like search tools, we try our best to help users find their taste and explore new possibilities. But this also creates a new complexity for users to navigate the content, because like when it comes to search, it's often very hard for users to rely on words in the text to very precisely articulate the complex intricacy across the multiple fashions, lifestyle, and the cultural elements. And users can also use images to search to capture the rich elements. But when you start to use image, you start to lose the explicit expression of intent, which often results in the failure to capture the specificity in like which direction you actually want us to refine and explore, starting based on a image itself. So these are some examples here, right? So when you see these elements, so these all of these codes, it's really hard to say like what color or what style or even like what kind of taste it expresses in these images. So this is why we created Hybrid Search, a multimodal approach that will provide a new tool to search with both image and a text. So user can start with a pin. A pin means an image on Pinterest. This is the starting pin that serves as a like beginning point of your refinement. Then we allow the user to specify a modification to the pin. This modification can be a like color or a style or a location. And then we will provide the search results in a different color or a different style and pattern, etc. You can also choose an object in the pin. Like for example, you choose this hat, and then you will be able to specify all these attributes as well, and we will return the real pins having those attributes, but still remain similar to this pin or the object that you have specified. And this is the system at high level, how we do this. So the system is still a search system that includes the query recommendation, multimodal retrieval, ranking, and re-ranking. And there are 4 key elements that make it work, for which Sana and Irene will go into more details. But briefly, we have multimodal representation that produce embeddings for image and the text and put them in the same space that easily we can operate on them. And we have vibe understanding that makes sure the important semantics in the images are handled correctly. So the images will have the correct like style and the color and all the fashion elements. We have a query recommendation system that recommends text queries with high relevance and high utility. And we also have object understanding unit that extends the whole experience into single object. And then let's pass to Sannan, and she will introduce to you how the text query recommendation works.
Yep, thank you, Zhenjie. So to help users to get started with Hybrid Search, or provide with some text recommendations for users to get started. So for now, the recommendation is based on the attribute taxonomy. And you can see here are some common attributes which are applicable for most women's fashion objects. And they are color, style, occasion, texture, fabric, season, and pattern. And we also have some specific attributes which are only applicable for a specific object type. For example, we have lower body length for only dress or skirts, and we have shoe height for shoes, and we have sleeve length or neckline for top. So we will decide what attribute types to recommend according to the object type we detect in the pin. And after that, we will ask Gen AI to provide us with some recommendations about the specific attribute values. So we will provide GPT with the object type, color, style, and occasion that we detect in the pin. And we will ask it, what would be the most popular attributes that user will be interested in exploring together with this pin? And we will also provide it with a predefined list so it can pick the most relevant value from. And here, let's look at this pin as example to get how recommendation works. So for this pin, I would mainly describe it as a red skirt for weekend occasion and in romantic style. And based on that, we will recommend occasion, color, style, pattern, lower body length, and texture. And GPT gives following recommendations. So the first one is cocktail, which is for a more like semi-formal settings compared to the informal weekend settings. And we have pink, which is a substitute of red, which also complements the romantic style. And we have bohemian style, which is suitable for the weekend occasion. And we have graphic pattern to add more like modern style into this romantic dress skirt. And we have floor length for people who are looking for skirts for more formal occasions. And we have beaded to add intricacy to this romantic skirt. Next slide, please. Cool. So we also mentioned we have object level hybrid search. So if user just want to focus on a specific object, and for example, this skirt, then the recommendation will be quite similar to what we mentioned before. But the only difference is instead of only recommending the most relevant value, we also provide some other options for users to choose based on their preference. So they can like explore more possibility from hybrid search. Next slide, please. And there's another object in this pin, which is this yellow pump. So if user wants to focus on this object instead, we will recommend something different. As you can see here, we have shoe height and season instead. So for users who are looking for maybe mid-calf pump, which looks quite similar to this yellow pump, then they can achieve that by using hybrid search. Next, I will pass Irene to talk about how we generate the feed.
Thank you, Sainan. I will talk about how hybrid search generates the feed and ensure high quality of it. Let's say if a user selects this pin of a lady dressed in pink business casual suits and wants to change the color to yellow. The backend would embed the reference pin and the text query to the same embedding space, then sum them up to get a hybrid embedding. The new embedding will then be used for retrieval. As for the specific embedding, we use our Pinterest in-house embedding model, SearchSage. Next slide, please. So the goal of the model is to find the pin that the user will most likely engage with a given string. For context, the model consists of two towers, each generating an embedding for pin and an embedding for the query. And then the resulting two embeddings will then be applied a dot product to get the cosine limit similarity score, which indicates how likely users searching with this query will engage with this pin. This model is trained on engagement data and with a contrastive loss that encourages the model to predict a label of 1 for the engaged pin and 0 for non-engaged pins. So we noticed that when we simply sum up the embeddings, the hybrid embedding doesn't seem good enough. The feed was either not relevant enough to the reference pin or not relevant enough to the text query. Therefore, we came up with some attribute optimization approaches to improve feed quality. We started out looking at the attributes of the reference pin. A pin usually has many attributes. For example, this one pin has a pink color, a solid pattern. It's made of cotton, has a classic style, and it's probably meant for business casual occasion. We need to decide out of this many attributes, which ones are important and which ones are safe to ignore. First of all, the user is trying to change the color, so the pink attribute is definitely not relevant here. And then we decide that the business casual occasion and solid pattern are two pretty important attributes that define the complete vibe of this pin. With this knowledge in mind, we have an improved formula of the hybrid embedding. Next slide, please. So we still use the reference pin embedding as is. As for the text query, we augment it with the important reference pin attributes, as well as the object name. Therefore, the query would turn from yellow to yellow solid business casual suits. On top of that, we also subtract the embedding of the undesired reference pin attribute, which is pink. We found that with this formula, the resulting feed becomes much more relevant to both the reference pin and the text query. Next slide, please. So besides the improvement on the hybrid embedding, we also apply optimizations on the blending layer. Specifically, we move up pins that match the query attribute and reference pin attributes, and also reorder the pins so that the top view pins always have matching attributes. Here is an example. The reference pin is a pink floral dress and the query is in white. You can see that at the top of the feed, most pins would have are floral dresses matching the pattern attribute of the reference pin. But as you scroll down, you will see more diversity. Like there would be dresses that are solid instead of floral. This is because of the optimization we did in the blending layer. Finally, I am going to talk about some examples that show how attribute optimization help improve the feed quality. Let's say we have a reference pin of a blue business casual suits, and the query is in white. The first column has no attribute optimization at all. And you can see that the resulting pins don't really look like the reference pin in terms of style and vibe. So in column 2, we add attribute preservation, preserving pattern, occasion, and style. And then the results become like much more relevant, I would say, to the reference pin. They're like all business casual suits. However, we need to be really careful about which attributes to preserve. Here is a bad example. If the query is for active and if we blindly preserve all the attributes, including the classic style of the original pin, then the resulting pins wouldn't look like activewear as well. This is because the style attribute conflicts with the query attribute. Therefore, we introduced a set of rules that decide which attributes to preserve based on the query. So when the query is for active, we want to preserve the style attribute, and that leads to much more relevant result, as shown in column 4. So I will then pass to Zhenjie to talk about experiment results and summary. Zhenjie, you're muted.
I'm sorry. So thank you, Irene. And together for the with the optimization methods, we also created an evaluation methodology in which we evaluate the relevance of the results to both the text and the image. And the text relevance are measured in 3 levels, as shown here, text relevance, and the image relevance are measured in 5 levels, and then they are combined into one number that it's mapped from 1 to 5, and then we measure the quality through human evaluation. These results are the first round of the evaluation we did earlier in the year before we had all of these refinements that you have heard just now from Sanan and from Irene. And the average relevance of hybrid search was 2.9, which means it's very close to 3, and the relevance is apparent to human eyes. The control of 1.8 was for regular text search, and the difference between 2.9 and 1.8 is actually larger than it appears to be, as the baseline minimum score is 1, not from 0. And with this additional improvement, so we expect to see the ongoing next evaluation to yield much better results. And we have also conducted online experiment. Hybrid search showed a much higher, roughly like 4x engagement rate compared to regular search. So to summarize this up, this project is at the starting stage. So at this stage, we have shown the effectiveness of a multimodal framework with multimodal embedding, text query recommendation, fashion element, fashion vibe understanding, and object understanding. So in the next phase, we will be developing a much more advanced multimodal technology by leveraging the latest vision language models with cross-model attention and late fusion. And we are going to explore the conditional latency diffusion method that Eric Sun introduced in the last talk. We are also making better query recommendation in order to capture the most inspiring elements in the images, and with optimizations in both engagement and personalization. A multiple machine learning system relies heavily on the amount of quality of training data. We are making a lot of effort in creating a large set of training data in which is critical for these large machine learning models. I hope we have provided you with a big picture of what we are excited about in the multimodal technology. Thank you all for your attention and the engagement. Your interest means a lot, and I'm excited to hear your thoughts and questions.
All right, thanks everybody from the HyperSearch team. It's very fascinating to see how multimodal modeling and LLMs can help our partners create a life they love. Now we have the group to answer any question the audience may have. All right, the first question: would the attributes in the text recommendations be different for each user, or is it purely based on what's in the image?
Sandan, do you want to take this question?
Yeah, for sure. So for now, the recommendation is mainly based on like what most people would be loving to see, but definitely personalization is something we want to develop next year. And we want to do recommendation based on what pings user previously saved and what queries they previously searched for. And we know different people have different tastes. So definitely personalization would be an important thing to improve.
Cool, thank you. All right, one more question. Do you use a closed list of attributes for each object type? If not, how do you ensure GPT does not hallucinate while recommending attributes for a particular object type?
Yeah.
So
go ahead if you want. Yeah, sure. So currently we do use a closed list of attributes. So we have a number of different attribute lists, which Sana has just introduced. For the other option is to use GPT to directly make recommendations on these attributes, right? So this does pose a lot of significant challenges to us, and the hallucination is just one of them. So we are taking this is one of the options we are testing and carefully proceeding in the back end. And there are a number of challenges that we have to overcome in terms of like whether this is appropriate, whether the GPT is actually generating very inspiring and exciting recommendations, how to scale this technology up. And specifically to answer this question of hallucination, we will need to install like the mechanisms of evaluation by human and train a model to automatically classify whether there's any problem in the GPT generated text recommendation or not. Like this model need to be independent from GPT, and probably also need to have like multiple models to check in the same time. Yes, thank you for the question. This is really good.
All right, thank you. And thank audience for the great questions as well. Next up, we have privacy preserving conversion modeling by Kungang Li, Xiangyi Chen, and Jiankai Sun. So let's hear the presentation.
Okay, thanks for the intro, Jacob. Good afternoon, everyone. My name is Kungang from Pinterest Ads. I will talk about the privacy-preserving conversion model in the data clean room together with Xiangyi and Jiankai. So here's today's agenda. So the main focus of this work is ad conversion rate prediction. It means the process of estimating the probability that a user will make a purchase or sign up for a service or other conversion activities after they interact with the ads. It is very crucial for the ads industry because it helps to optimize advertising can improve the user experience, help to measure the ad performance, help to allocate resource, and provide a competitive edge. However, some advertisers are not willing to share their conversion data with advertising platform in order to protect their data privacy and maintain their competitive advantage. So the data clean room is an option those advertisers are interested in sharing the conversion data in a more privacy-centric way. The data clean room is a secure environment for multi-parties to collaborate on the data analytics and extract insights without exposing the underlying raw data to each other. It functions as a trusted platform through its secure and compliant setup. The data clean room can be used for the data matching from different sources and to do collaborative analytics. It has multiple benefits, such as enhancing the privacy by protecting the sensitive user data, to foster the collaboration between multiple parties and provide valuable data-driven insights, and can support the compliance with data protection regulations. In the meanwhile, it also has a few limitations which restricts their usage to our scenario of conversion modeling. It is mainly used for SQL data analysis and has limited computing capability, and it enables very limited visibility into the model training logs, and it may trigger high cost. To overcome the limitation, we leverage the idea of split learning, which aims at collaboratively train a model using the private input and the label data held by two separate parties. So in high level, we employ the parameter-efficient fine-tuning technique, differential privacy, and the communication-efficient training algo to comply with the privacy restrictions for conversion data and enable the efficient coordination between clean room and advertising platform to train the CVR model. Next, I will hand over to Jiankai to talk about the model training framework.
So thanks, Kungang. So I will talk about how to build models with data clean room. So there are three parties in the framework: the advertising platform, the advertiser, and the data clean room. During the model training, the platform will take the input features and send the features to its own neural network F, and get the prediction logic and the corresponding prediction probability. The platform will send the prediction logic and probability to the data clean room. The advertiser owns the ground truth labels. To protect its privacy, the advertiser will add some perturbation to the labels and get the noisy label. The advertiser will send the noisy label to the data clean room. So the data clean room can join the prediction score and the noise label, so that the data clean room can calculate the loss and then calculate the corresponding derivatives of a loss with respect to the prediction logic. Also, the platform also has to send the derivatives of logic with respect to the neural network F to the data clean room, so that the data clean room can combine these two derivatives and calculate the final gradients based on the chain rule. Then the data clean room can send the final gradients back to the platform, so that the platform can update its parameters based by the gradients. So that's the framework of with data clean room. Next slide, please. So next slide, Kunal. So previous, yeah. So let's analyze the information shared between the model training. So for the advertising platform, it has to compute and send the logic and the derivatives of logic with respect to the parameter to the data clean room. And the advertiser has to add some perturbation to the ground truth label, so to protect its privacy. And later, Xiangyu will talk about how do we use label differential privacy to protect the label privacy. And also, the data clean room has to join the label and the logic to get the loss and calculate the final gradients. So the data clean room has to send the gradients back to the platform. And Xiangyu will talk about how do we reduce the computing cost later. Regarding the serving, there's not necessary to share information between the platform and the data clean room. So the platform can do the serving itself. I will handle the slides back to Xiangyi to talk about how do we,
Yeah, as mentioned by Konggang and Jiankai, one of the major bottleneck in the framework is the communication between the advertising platform and the clean room, because we need to send the per-sample gradient back and forth every time. So to cope with this problem, we propose to use adapter-based methods for efficient training. More specifically, we use LoRa to fine-tune a pre-trained base model without using the advertiser's data, and fine-tune on the advertiser's data in the clean room. The LoRa method is commonly used in error fine-tuning, and the idea is to freeze the weight, then fine-tune a low-rank adapter on top of the weight. This can be applied to any linear layers in the model. Next slide, please. This page shows how we apply LoRa in our conversion model. Our conversion model is pretty much similar to other industry ranking models, and there will be some feature processing layer. There will be some specialized modules using transformer or other different architectures. And finally, there will be some MLP layers producing the final scores. There are a lot of components involving linear layers, and we apply the LoRa adapter to QKW layers in transformer and feature interaction modules, and also the MLP layers in the multitask tower. With this LoRa technique applied, we can reduce the number of trainable parameters to way less than 1% while preserving the performance improvement, making it comparable to the full fine-tuning. And this will have a very less communication cost and better privacy guarantee. Optionally, we can also use gradient compression methods to compress the per-sample gradient in cases where there is a limited communication bandwidth between the advertising platform and the clean room. Next, please. As mentioned by Jiankai, we need to protect the label privacy. In this part, we apply the label differential privacy to the labels. Essentially, we flip the labels with a fixed probability before any processing of the labels. This can be done on the advertiser side before sending the data to the clean room. And this can prevent reconstructing the labels in any form using the data transmitted in the clean room. Next, please. But one of the issue when we apply this label DP directly is there will be significant amount of noise added to the labels, and this will make the model very miscalibrated if we train directly using the noisy labels. To deal with this problem, we also proposed a correction in the loss function. The idea is we instead of adding the loss function to the true prediction of the model, instead we use a Bayesian rule to calculate the prediction of the observed probability in the noisy data, and then we apply the original loss functions all to the y observed, which is the prediction of the observed conversion probability in the noisy data. And in this case, we can make sure the true prediction of the model is still calibrated. Next, please. This page shows the results for LoRa fine-tuning. The setting is we simulated this clean room setting using our in-house data, and we separate a big advertiser's training data out from the conversion model, and then we train a model without using the advertiser's data, and then we fine-tune our model either using full parameter or using low-rank adapter using the separated advertiser's data. We can see, compare with the full fine-tuning and the baseline, we can get more than 3% gain in ROC AUC. This will translate to a very strong online gain in our experience. And even with LoRa rank 1, we can still get more than 3% gains while reducing the number of trainable parameters to way less than 1% compared with the full fine-tuning. Next, please. Here shows the label DP and gradient compression result. As expected, these techniques will reduce the model performance because they are trade-off between privacy and the communication. But as we can see from this page, all these reduction are less than 1%. If we combine them together, we still get more than 2% gains on the advertiser's performance if we do the math. Next, I'll hand over back to Kungang for the conclusion and future work.
Thank you, Xianyi. So here are our conclusion. This proposed framework achieves competitive CVR prediction, and in the meanwhile can significantly reduce the communication overhead. This approach also balances the effective advertising with user privacy concern, and it may influence the future research in the privacy-centric online advertising industry. And if you are interested in more information, you can refer to our work published at Rexis 24. And we also would like to thank a lot of collaborators for their valuable discussions and insights.
Great.
That concludes our talk.
Yeah, thanks, team. Very meaningful work in providing this privacy-safe solution to our advertisers who come to Pinterest to drive conversions. So we now have Kungang and Jiankai and Xianyi with us for 5 minutes for Q&A. All right. The first question, how aid the scalability of this framework? Can we scale this to multiple advertisers?
I can take this question. And our short answer is yes, it is very scalable to multiple advertisers. Basically, because we use the gated LoRa adapters in the model training, and to scale to multiple advertisers, we simply just need to add dedicated LoRa adapter for each advertiser. So the gradient computation, the communication with the clean room server for each advertiser, and the model weight update can be done independently and in parallel for the dedicated LoRa adapters corresponding to each advertiser. So it's pretty scalable.
Cool, thank you. Next question, is there any use or potential use of federated learning of Pinterest?
Jiankai, do you want to take this question or I can start?
Yeah, I can give you some points here. So as you can see, our data clean room solution combines both vertical federated learning and horizontal federated learning. So you can view as a combination. So the potential use of federated learning at Pinterest is for the CVR prediction. Maybe Kungang can add more details.
Basically, actually the current framework, we leverage the split learning, which is kind of like a vertical federated learning approach. And yes, in order to build a more privacy-centric online advertising, especially to collaborate with advertisers and also more responsibly to use user data, we need to build such more federated learning framework. Hope that answers your question.
Great, the audience has shed light on our future directions. Cool, so thank you all. We have 2 more talks remaining. Next up is ML Fairness of Pinterest, presented by Pedro Silva.
Hi, everyone. Thanks, Jacob, for the introduction. So if we haven't met yet, my name is Pedro Silva, and I lead the Inclusive AI team here at Pinterest. So we've been working on a machine learning fairness framework internally for some time. And today I kind of want to share a little bit of the process we took to basically explore effective ways to successfully build and adopt machine learning fairness at large-scale recommendation systems like Pinterest's. So I want to ground this conversation by first defining what is ML fairness, right? So machine learning fairness is simply the process of assessing, correcting, and eliminating algorithmic bias from machine learning models. Very simple definition, very hard goals to achieve, right? We do understand that every ML model is biased one way or another. So even defining what is the bias, assessing what actually metrics make sense for us to correct them is a huge part of discussion on the ML fairness community, right? So I think the definition speaks for itself on the motivation on why we want to do this, but I still kind of want to go over a few of the reasons why we should do this to begin with. So some of them, I kind of want to give you 3 main points. So the first one here is around social and legal reasons. So we really believe that we should be moving away from a lot of historical patterns of bias in society that we still perceive in a lot of the data sets we see it. This is true in any period of time in machine learning, right? If you were building a model in the 80s using data from that time, you'd probably have different biases than we have today, but you still have that reflection happening on your model. I like to say that we should build for the future we want to have instead of the present we currently are in, right? So, and also when you have these large scale systems that maybe are performing unfairly, this actually can lead to a lot of different types of harm. We have been seeing this in the news every week now with the boom of Gen AI. So, but this is not new, right? This is the same type of stuff that happens in a lot of common machine learning systems as well. And then, of course, there is legal reasons around this and moving ahead of regulation, making sure, like we see European regulation happening, we see a lot of that happening now in the US as well, even in state regulations, right? So there is a lot of regulation around AI and how systems should perform fairly across different types of groups. So there is a lot of motivation around this. Now, I'm a firm believer we shouldn't do this because some government is telling you should do it. You should do it because it's the right thing for your users, right? And that is actually my second point here. Putting this notion of putting your users first. Now, who are your users here, right? For us, there's, of course, a lot of different stakeholders at Pinterest. The first ones we tend to think about are opinions, right? Those are the folks that are coming to use our platform. We actually have seen that building more fair and inclusive models at Pinterest leads to a better, high-quality type of engagement we want to have on the platform, right? So these are folks that instead of just using, sitting down and using Pinterest for 15 hours a day, they are out there, they go and they go build something, they come to the platform, they have much more deeper connection with Pinterest and the use cases they bring to us. There's also better exposure for content creators and how our system scales in international markets, right? Because when you actually build a lot of recommendation systems that are more fair, you almost are intrinsically introducing some a notion of exploit in the system already intrinsically, right? So we have seen that helps a lot with new creators in the platform on kind of having their content shown across the board. And also on new markets, right? Pinterest is a very global platform. We have a lot of users spread out across the globe. So the notion of what is trending and what is cool, what is popular in the US versus Japan versus Brazil, all of those are completely different, right? So when you build fair systems, localization tends to be a big aspect of it as well. And then lastly, which is probably one of the things that resonates a lot with the group here, is the technical aspect of this, right? As the machine learning engineer, someone that builds the system, there is like a lot of technical components that go into actually making a system fair. Like we really believe that unreliable data, like biased data, will lead to unreliable models and unreliable evaluation of such models, right? So you may actually have a false sense that your model is performing greatly when in reality it's not, because your performance metrics that you're looking at may be lacking some sense of fairness, right? So you have this notion of undetectable errors, which basically mean you're not looking at a certain space that you should be, and that leads to bias propagation throughout your entire stack and ended up affecting the end user. So I kind of want to move us into the process we took to do this at Pinterest, right? So there were 3 main things that we were looking at the time. Data segments, metrics of interest, and systematic integration across our product. So let's start with data segments here. So for data segments, we're looking into basically like how to best group the data, right? Like how do you want to segment this data? How do you want to group it to evaluate fairness, right? Of course, we're talking about group fairness here. So we wanted to make sure we can group on something meaningful that can provide us with relevant information and also provide the consumers of this framework across the company. Now, one of the main things we really wanted to be mindful of, and as we heard in the previous talk, we really have to high focus on preserving user privacy at Pinterest, right? So we have pretty high bar on how we use user data such that we don't infringe their privacy. So one of the main things we did on this framework is we are not trying to evaluate anything on user data itself, but we are going to evaluate things on the content side, which is where we have full control of how we display this across the globe, right? Across any type of surface at Pinterest. So that was one of the decisions we made on this framework. Now, how do you do this, right? Like, you still have the same question, like, how do you segment data? So depending on how you're doing this at your company, you can use several different proxies as needed. Of course, still abiding by the first rule of respecting user privacy. For us at Pinterest, the Inclusive AI team has already done some work around inclusion and diversification on the recommendation and search. So we actually use some of those signals, such as skin tone signal, the body type signal, to basically evaluate the subgroups here. Now, here's one thing I'm going to say, and you're going to hear me repeating this point across this entire talk. Involve your customer, right? So, of course, we really care about some of these segments, and we want to make sure we are evaluating fairness across them. But we really want to make the system in a way that the customers of them, right, the owners of these models across the company, can also gain additional value beyond what we're proposing. So we made the framework in a way such that different consumers can actually bring additional segments. So just to give you an example, right, I have here an example of how home feed looks for a lot of folks, right? You have a travel pin, you have a fashion pin, you have a home decor, you have this notion of interest, right, on our platform. So for home feed, for example, it's really important for them to look into how different interests are matching with each other, because if you have a high unfairness there, you're going to have basically a takeover of home feed where you only see one type of pin, right, one type of content. So they want to make sure that doesn't happen. So this is just one example of how you can involve your customer when you even bring in data segments into this work as well. So the second part of this is looking at metrics of interest, right? So there's a few different types of metrics that we thought about when we were doing this. The first one, of course, is looking into data set metrics, right? So this is basically looking at data set composition, label distribution, feature coverage, feature distribution. There's like a few different ways to do this. And the whole idea here is that you should do this based on the segments you care about, right? The segments you're trying to evaluate. So we just have, you're going to see throughout the talk also some examples I have on some synthetic data just to illustrate what I'm trying to say here. So for example, we're looking here like data distribution by different segments, right? And you can see, you can look at this on your training data, on your evaluation data, different segments here. And you can just see if there's high imbalance, like right away you can see it, right? You can see on that one, for example, it's much higher there compared on the data set versus the corpus they have at that point. Also on the right side here, you have this notion of label distribution. It's kind of looking at the same things. It's just a histogram of label distribution. And again, here's the point that I'm going to continue to mention. Involve your customer, right? Having that type of information is something that you should have irrespective of kind of model you're developing. But what was interesting for us here is not just showing that, but kind of flagging to customers things that can act upon to kind of solve those imbalances already, right? So we have this notion on pretty much every section of our framework called action items, right? So when we see things, we do a few statistical evaluations, and we can actually provide some action items for customers already, saying like, hey, we see a very heavy imbalance on this. You might want to adjust the distribution of this. It's very likely going to impact the performance of the model for some of these groups. So when you give more concrete actions for the owners of those models, we saw a very high rate of folks actually following up on the action items and making the changes to make those models a little bit better. The other type of metrics we're looking at here is, of course, evaluation metrics, right? So this is looking at model, like common model evaluation metrics, but segmented by the segments we previously defined, right? Of course, you can think about, R-analytical raw curves, the precision recall, F1 score, FBRs. We do have all of those in this framework. So here's just like an example of how this looks, right? Again, I'm segmenting it by the segments of interest and also the different labels we have. And as soon as you look at this, you clearly can see like the difference in performance right across the groups you have. And that, of course, is something that we're going to flag on those action items as well. On the right side here, we have something similar, but looking at the score distribution, right? Basically looking at the probability distribution for some of these predictions as well. And I'll keep saying it until you really get away with it on this talk. Involve your customer, right? Like having all of this is very helpful. And again, this is something, if you're doing any type of ML development, you're already going to look into this. However, you may have not seen this on the specific groups we have, and that's the value we're bringing here. But one of the things we found really interesting is that every different model, every different team has what we like to call North Star metrics. So this is the notion of what are the metrics that we really care about, and they tend to be the decision maker when we're thinking about putting a model in production or not, right? Are we going to ship this model? Are we not going to do that? So if you can actually incorporate those North Star metrics into the framework, it also makes it very actionable for them because they can see literally like, oh, this is the metric we use and we're really underperforming for some of these groups. We need to improve that right away. So the third type of metrics that we're going to look at is, of course, looking at actual machine learning fairness metrics, right? I'm going to start by saying that there are over 20 different types of fairness metrics you can put into this framework and you can find in the literature. And also I'm going to say that not all the fairness metrics can be satisfied at the same time, and we know that very clearly. So the way we do it is we start with those three metrics, which are the metrics that probably cover most of the models that we have right now with the company, and they can provide a lot of value depending on the use case. Now, of course, the way we wanted to involve our customers on this is driving clarity, right? If you are someone that works on the fairness space, you work with responsible AI, you're probably very familiar with those three metrics. They come up in every single paper on the field. However, we shouldn't expect that every ML engineer in the world is familiar with this, right? If they're not working on the space. So what we try to do here is provide a very simple explanation. These metrics are not hard to understand, but if you've never seen it, it's going to be hard for you to actually take action based on what I'm just telling you here. So one, we provide a definition, and second, we provide an explanation here of how this might be affecting your performance. And of course, we still have action items there to kind of help them understand how they can make a change on their model to better that performance. Now, the last one here is talking about systematic integration. Like now we have this framework, this is kind of the thing we're trying to build. How do we integrate across the company? Now, the first thing I'm going to call out is a library is not enough. I can't tell the number of amazing fairness libraries we've seen out there. Some of them are way better than what we have built here, but it's still a passive ask, right? You're still asking folks like, hey, here's something I built, please adopt it. And what we understood from the beginning is meet your customers where they are, right? So that means understanding where the models are trained and evaluated. And at Pinterest, we have an amazing ML platform team, which has built some systems internally where basically like over 90% of the models are trained on that type of environment, right, in a machine learning environment. So we actually went and built a job there. So now it's much easier for any team that uses that platform to basically integrate our machine learning framework into the workflow for training any models. That means any model they train or retrain already produces a machine learning fairness report, and they can just look at that. The second thing here is similar on like understanding like where are experiments run in your company, right? If you're trying to launch something, which platform you use, and integrating fairness measurements there, because that's where the decisions are made, right? If they get to a forum where they're trying to decide, having the visibility over those metrics is really important. Third, looking at model performance dashboards and alerts after this work is completed as well, right? Because after you launch and you're all done, you still want to monitor this over time to understand if metrics are degrading or how they're moving over time, so they can actually act on this if anything goes awry. Fourth point here is looking how you can adjust for different types of models, right? There's a lot of work in the literature on classification models per se, but at Pinterest, we're definitely not limited to this, right? We have so many different types of models, from like ranking models, retrieval models, embedding types of models. So we build a framework that can support different types of models and also have that type of the same level of information available across the board. Of course, you can't do this all at once, so I'll say prioritize the ones you can do it first, and then you can build up from there. And then lastly, as pretty much any type of work around responsible and inclusive AI, it's not a one and done, right? So having this notion of continuous tooling improvements, both improving the tooling itself to make things better, to make things easier, to make things faster, but also supporting new types of metrics, new types of models, and making sure you maintain things up to date as you go, And that really helps customers adopt and kind of reuse the insights that you're providing them with this. So kind of just want to wrap up here with a conclusion. I hope if you were taking one thing out of this talk is involve your customer, right? We do understand when we believe firmly that fairness is something that's really important, but it's also really important to involve customers in the process of how they're going to use these metrics, how they're going to evaluate, and what else they can take out of the system besides what you're just trying to propose to them. Also, make sure to integrate the framework in the platforms they already use, right? It's much easier for them to actually adopt this and take actions based on it if it's in a place they're already used to, on a platform they're used to use, instead of just being one additional step, one additional thing they have to look at in a completely different platform you're trying to build. And then the other 2 points here is just understanding that fairness should be part of any healthy model development system, right? This is one of the things we see a lot on folks that are starting to build models right now, and they already started using this. They have much higher success on building systems that are unbiased, rather than integrating much later in the process. That's not to say you cannot and you should not do for the other models, but just saying that you should start on this as early as you can. And then mitigation is something, of course, that if you find imbalance, you're going to need mitigation. But folks often like to say, like, hey, we need to start mitigation work right away. And I think there's a lot more work to be done on understanding where there are problems, how you can mitigate them first. And as it comes to mitigation, there's many ways to do it, right? Of course, looking at the data report is probably one of the most helpful things for us. There's in-processing methods, there's post-processing methods you can do. You can change your loss function to account for some of the subgroups, etc. And then the last point here I want to make is just this understanding that fair ML models are simply better machine learning models. For any company that is building something that's going to have a global reach, you really need to understand how to nuance your models such that they perform equally well for everyone that's going to be using your product. And that is ultimately our goal as a company. And with that, I'm going to pass back to Jacob for a Q&A.
Great, thanks, Pedro, for putting fairness first and bringing this important ML fairness issue to our attention, and also sharing your learnings. So yeah, we can open it up for Q&A. All right, first question up. Does this framework support generative AI use cases?
It's a great question. So I think the way we're looking right now at Gen AI within Pinterest is we see a lot of problems even beyond the fairness problems that I mentioned here. So we're actually designing a larger system to kind of deal with that, where fairness is just one aspect of it, right? Like for example, on Gen AI, we see a lot of issues with fairness, inclusion, diversity, like erasure harms, cultural harms, hallucinations, so many different types of issues. And then if you look at Pinterest as well, we have a lot of different types of modality of data. Like we have textual data, you have Pinterest Canvas that Eric was presenting earlier. So text to image, text to text, you have video, you have like so many different types of modalities. So the question for us has been, how can we build something that can measure all these different types of harm across the board and also across different types of modality, right? So this system is not specifically, doesn't specifically support Gen AI, but it's part of a much larger system we're building actually called Empathetic AI to kind of have visibility over the entire Gen AI space as we go.
All right, thank you. All right, any more questions? Yeah, if you have any questions for Pedro, please ask in public chat. All right, I think we can move on to the last lightning talk. Thanks a lot, Pedro. Yep, and yeah, here have a last lightning talk. We'll have Karthik Jayasuriya to discuss Uniformer for ads retrieval.
Yeah, thanks, Jacob. Good evening, everyone. Thank you for being here. My name is Karthik. I'm from Pinterest Ads team. Today, I'm very excited to share how we used Pinner-Former model for sequence modeling in ads retrieval. So here is the outline that we'll cover today. So first, we'll start by looking at some conversion data concepts, especially what are identified match conversions, followed by the pinner former architecture. This is like an in-house architecture built by ATG team a couple of years ago. And then we would look at a couple of use cases where this model is successfully used to retrieve both relevant advertisers and relevant shopping ad pins for our pinners. And finally, we'll conclude by some summary and improvements. Okay, so first, let's go to what is conversion data. So Pinterest advertisers send us event logs that happen on their app, website, or physical stores. So these are called conversion events. So when Pinterest get those conversion events, the user match team at Pinterest maps these conversion events back to a specific pinner, and these become identified match conversions. So that's what's kind of highlighted in yellow. And let's say we are able to map a specific event to a Pinterest user, Stephanie. And let's say Stephanie saw an Allbirds ad on Pinterest and 5 days later bought a pair of shoes from Allbirds. Then we can say that that specific purchase can be partly attributed to the ad seen on Pinterest. So most candidate generators that are currently in Pinterest funnel are based on these identified attributed conversions. But today we would look more about identified match conversions, which is a much larger set than attributed conversions. So specifically, the match conversion candidate generator that uses this match conversion data, the goal here is to surface top relevant advertisers for that pinner. So if we kind of look at a sample offsite conversion history, so here is a pinner who is interested in some exercise gear like shorts and dumbbell, which are added to the cart and later checked out with a shoe. So here the goal is to predict some fitness related advertisers for this particular pinner. In this case, Mile 45 and Blugzome, these are some fictional brands, but the goal is to kind of predict relevant advertisers based on their sequence of offsite conversion history. So let's zoom into the model details. So as I said, the pinner former architecture is an in-house architecture developed specifically by ATG team, Advanced Technology Group team at Pinterest a couple of years ago. And it's also published in KDD conference. So in short, it's a user sequence model that takes in user on-site engagement history, such as like repins and close-ups, and try to predict what the pinner might be interested in a future window. So in the diagram that we see, we feed in like 1 year user sequence of engaged pins on site and try to predict what they are going to engage in the following 28-day future window. So now we'll take this architecture and see how we adapted it for advertiser retrieval. So on the user side, we now represent the user sequence with the sequence of offsite conversion events, where each event that is shown in the yellow box is enriched with like advertiser features, conversion type, which is like add to cart, checkout, or sign up, and then the specific timestamp the event occurs. And these events are represented in a specific representation layer, the output of which goes through a unidirectional transformer with causal masking. The reason is we want the transformer to attend to past and present actions, but not the future actions. And the output of the transformer goes through a user MLP in order to generate user embeddings at any given time step. So that's on the left-hand side. On the right-hand side, we have an advertiser tower. It has its own representation layer and advertiser-specific MLP. And this tower can generate both positive and negative advertiser embeddings. So the positive embeddings come from events that the user interacted with and those advertisers from those events. And the negatives come from the non-interacted events for that specific user. So both the user embeddings and in conjunction with the positive and negative embeddings together are fed into this all action loss, which I'll go in a little bit. And that is what is used to train the model. Quickly looking at training data used for this model. So essentially, as I said, it's a sequence of conversion events for across 6 months, kind of split into training of 150 days and 20 days following the training for evaluation. Each event that is shown in this diagram as a circle is represented as advertiser ID and conversion type tuple. That is a unique identifier for that particular event. And positive events in this case include checkout, add to cart, and sign up. So those are the green circles in the purple shaded box. And that's what the model uses as labels to train on. And coming to the loss computation, essentially all action loss mean that we take the most recent user embedding or the very user embedding at the very last time step and try to predict the positives in the next future window. So here you would see every arrow kind of connects a user embedding to a positive event. And for each arrow, we would compute a loss. And this loss is aggregated across all the pairs that are shown by these dotted arrows, and then across all the users that are weighted average to account for the fact that different users might have different sequence lengths. So essentially, we would get like one loss value across the whole set of user sequences. Just little zoomed in into the loss function. So we use sample softmax loss, which is a variation of commonly used softmax loss typically used in contrastive learning. So specifically in this case, we apply log-Q bias corrections. This is done to correctly account for the sampling bias that is typically happens in recommendation system datasets. And these corrections ensure that popular items don't get unfairly demoted. So specifically for a given pair, these log-Q bias corrections are applied for both positive and negative examples, as shown in these, as shown by these red dotted lines. Also, in order to compute these bias corrections in practice, we use a frequency counter, and the original Pinnerformer uses a count-min sketch. In this case, we adapted to a slightly different method using streaming frequency estimation. So this is done to kind of ensure that the training loss curve is a little bit more smoother and also provide more training stability and help with model convergence. So that's how the model is trained. So let's look at how this fits into the overall ad stack. So what I've described is essentially in this box, match conversion candidate generator highlighted in green. So what happens is when an ad request for a given user comes in, the match conversion candidate generator selects or predicts the top advertisers. And from those top advertisers, we pick eligible ads, and those pool of ads get sent to the lightweight scoring model, and the top candidates are basically capped to a specific predefined quota, and that's what the match conversion candidate generator helps to pick the specific ad candidates. Now we have different kind of candidate generators in production, so all the candidates from all the CGs gets blended, and they get ranked again with the lower funnel ranker, and the top candidates from that get sent to the auction for showing to the users. So this model is launched to both standard ads on the main surfaces at Pinterest like home feed and repin, which pretty much get 2/3 of the traffic. And the significant amount of time also goes into how to set this CG quota to make sure that the overall CG quota is consistent before and after, but then like how to do the allocation for this CG in conjunction with other CGs. And on top of that, we only trigger this for users with high commercial intent. So specifically users who are who have this high user measurability score, which is a heuristic that kind of measures how interested the user shopping, how interested user is ready to do a shop. So and then we kind of pick users based on the score and only trigger CG for this. So if you look at the results, it was very promising across all the key metrics, especially for both advertisers in terms of driving more conversions and reducing costs as measured by the CPA and conversion volume, which are statistically significant overall and also across the standard ads. as well as driving more relevance to pinners as measured by CTR and relevance scores, particularly across related pin surface. So we looked at the first use case, which is advertiser retrieval. So now this is the second use case. It's a more granular retrieval, which is retrieving shopping pins. So obviously the scale of the shopping pins is much larger compared to the scale of advertisers, just because the nature of the number of products that a given advertiser can provide can be very large. So in this case, it's almost 1,000x more. So given this scale, instead of relying on exact nearest neighbor approach, we kind of leverage the instead of exact approach, we leverage the approx nearest neighbor approach, where we first compute pin embeddings, and then we compute their IVF index on top of pin embeddings, and we use the index to retrieve the top K candidates that the user might be interested in. So that's on the pin side. And for the user side, we have a daily batch shop that refreshes user embeddings with recent actions from the past day, so that the embeddings are kept fresh. And both these embeddings are used to do the ANN retrieval. Again, like one main difference is, given this is happening at a shopping pin level, we need to additionally enrich the events with pin features, specifically capturing product semantics, product category, interest, and so on and so forth. So that's on the feature side. So when we come to the modeling side, we made a few optimizations to account for higher scale and also the sparsity that comes with the scale. So first thing is we expanded positive labels. So previously we looked at higher intent actions like add to cart and checkout, but that might introduce label sparsity. So we expanded to more secondary intent actions like page visit, page search, category, so that can better address label sparsity. And compared to advertisers, the shopping pin distribution is quite different. It follows a strong power law distribution. So we had to tweak with different kind of sampling and ended up with mixed negative sampling, which is the mix of both in-batch and random sampling to get the best of both worlds, and use that to train the model. And generally, the item retrieval task is a little harder intrinsically. So we relied a lot on the actual visualization of model predictions to manually vet whether these model predictions make sense, given this is a user sequence. So we kind of looked at predicted item pins, what are the categories, whether they make sense, whether they are related to a user shopping history, and so on and so forth. And we essentially baked visualization as one of the metric to pick the model. So the final model is selected based on few sets of metrics, but primarily driven by performance, which is measured by recall in this case, as well as diversity. So diversity is, we don't want to pick popular items for all the users. So we want CGs to be a little bit more diverse. So we kind of captured the distribution of how the popular items are spread across different user retrieve results, and baked that into a score, and essentially did a trade-off with recall and popularity and picked the best model to move forward with. Just quickly looking at the model architecture. So very similar to the advertiser retrieval, but the main change is on the right side. Instead of advertiser tower, we have the item tower, which is the shopping pin. And we can see that all the events are now also enriched with shopping pin features in addition to the other features. And similarly, we have to build a corpus of random index that is representative of the corpus of items that we see it online. So we want to make sure that there is minimum offline discrepancy. So we have to ensure that distribution is similar, and rest of the architecture is very similar to the previous one. Yeah, so this model is also launched into both home feed and repin surfaces, about to be launched. And the only changes here being the users now, in addition to being triggered with the previous heuristic commercial intent score, we also made sure that users have minimum number of conversions to maintain signal fidelity for those users, and also iterated on how to best allocate the CG quota in conjunction with other CG quotas. So as we can see in terms of results, gave stat-sig improvements in both CPA and conversion volume, particularly across shopping ads, as that is the segment that we're targeting with, as well as driving relevance to pinners as also measured by click-through rate for different surfaces. So yeah, so to conclude and to summarize, essentially we basically have shown that match conversion data are very effective to surface relevant advertisers and ads to pinners, while also helping advertisers better optimize their conversion campaigns. And particularly in this case of sequence models, we found that utilizing sequence information greatly improves personalization and helps to meet pinners where they are in the shopping journey. So I think that is essentially captured by the sequence information. And if you look at where we go from here, these are some of the improvements that the team is working on. At high level, they are around these areas. Like firstly, we want to improve shopping pin representations much beyond what we currently have, essentially to capture more pin semantics at a much granular level, and also combine that with the multimodal nature of pins. Like as we have more images, multiple images and videos, we can better represent the pin representation. That will help for better pin embeddings. Not only that, it will also help with the cold start scenarios, especially when we add more content-based features. And secondly, we want to improve responsiveness to generally on the user side and on the advertiser side. So currently, user embeddings are updated once a day. So if we can update the embeddings as the conversion events come in more real time and keep the embeddings more fresh, we can capture more recent user tastes, and we can adapt to that. Similarly, on the advertiser side, advertiser campaigns are dynamic and can change every day. So can we make the model predictions more fresh and more responsive to changing advertiser distributions generally? So that's one of the other kind of work stream. And finally, we looked at offsite conversion data and match conversion data. So that is capturing user shopping behavior outside of Pinterest, but sometimes that can also come with gaps. So can we combine that with the on-site data that is captured across all the platform surfaces in Pinterest, like typically the home feed, repin, and search? And can we combine the offsite and on-site data sources to better complete user sequences and better understand pinner shopping journeys? So, so these are at high level some of the improvements we are thinking about. Yeah, so that's to conclude. Match conversions represent a unique data source for us to help with personalization, and I think there's still a lot of room to go. So please stay tuned for all the future updates that come from this effort, either through Pinterest, blogs, or papers, etc. Yeah, so that's all I have for today. I think it's time for Q&A, Jacob.
Great, thanks, Karthik. Very impressive to see how you apply sequence modeling to ads retrieval and then achieve very amazing results. So yeah, let's hear the questions. All right, first one from Marnie. How far out do you or can you look to feel confident that feel confident that your attributed conversion is correct?
Can you look to feel confident attributed? I see. So so this particular work stream is actually kind of not affected by this problem because it is working on match conversions. So there's no like attribution in this case, but there are definitely other models that are relied on attributed conversions. And I think the teams are constantly trying to improve how we can better measure attribution and how that better aligns with both advertiser value and user value. So I think that's always like a constant process of improvement, and that's always done in conjunction with advertisers. So I think for this effort, it's less affected, I would say.
All right, second question. Curious, do we have an offline online performance comparison between Panther retrieval and batch negative sampling to target retrieval?
That's a great question. So I think we first tried with just in-batch negative sampling, and we found that that's adding a lot of I mean, in-batch negative sampling is good to capture like training data distribution and make sure that we apply corrections to account for bias. But it's not really good for capturing niche and long tail items, whereas random sampling kind of injects those into the negative pool. So we did some trade-offs between the two and ended up realizing that like the mixed one is doing better than just pure in batch, and we had to tune how to kind of combine the negatives from each kind of sampling to get the total negative pool. So I think for us it's basically determined by experimentation.
Well, glad to know the team has thought through this. All right, last one. When you go for events with higher commercial intent, you may get the ads relevance, but do you think or have observed that the non-commercial intent points were exploring the user style? Does Panther use the non-commercial events to better understand personalization?
Non-commercial intents. Okay. So I guess during training, we don't do any filtering based on commercial event, if I understand correct. So this is only done at the time of serving. So while training, we try to include as many events as possible, both high and low commercial intent. So we don't drop any signal that could be indicative of what the user is shopping for or looking for. The reason we drop it at the serving is because we are kind of trading off with other candidate generators, which might bring good advertisers. So we don't want to give full credit to one kind of data source CG. So that's why I think if tuning the CG quota in itself is a challenge typically, and that has to be done based on some systematic model based or heuristic based score in order to kind of drive this for users with high commercial intent. I hope that answered the question.
All right. Thank you so much, Karthik, for your time. And with that, we concluded all the lightning talks for today. So thanks again to all of the presenters for presenting these fantastic talks that showcase our cutting edge for PMO. But next, we have a 15-minute break. After that, we will go into a technical panel where ML experts will discuss machine learning strategies that will shape up the future recommendations, content discovery, and foundational models that they drive the next big bets for Pinterest machine learning. So stay around and see you very soon.